Hello, Precalculus students. We have been met with the technical misfortune of getting most of the way through what I consider to be a fairly smoothly made video, upon which we lost all progress. So, here we are back again with two pieces of good news. One, because I posted 2 weeks of assignments last week, there are going to be no new assignments this week aside from what has been already posted that I will collect at the end of the week. And two, while I acknowledge that trigonometry has been a bear and has been a very challenging topic, let alone precalculus as a whole, this week's assignments aren't as terrible as the ones that you faced in previous weeks. And right now, I'm going to walk you through the first one. Let's look at more radian exploration. By the way, if by chance last week you checked out more radian exploration and miscellaneous trigonometry, this week you're going to be working on these other two assignments. But let's jump right in. For equivalent functions of radian angles, once you get what this problem is asking you for, it's going to be a snap for you. So what we're going to do, I am going to walk you through two ways of doing this problem, after which I will turn you loose with the rest of the homework on your own. So first I'm going to take a screenshot. As with all successful math problems, we're going to draw a little diagram of the coordinate plane and kind of assume the unit circle. So we want to first say, where's pi over 6? Let's draw a better coordinate plane. That wasn't much better, but it's the best we're going to do. So pi over 6 is going to be, it's going to correspond to a 30-degree angle. I'm not great at drawing these, but it'll end up about here. So what we're going to do is we're going to plot the other ones on here. Negative pi over 6 is just going to be that reflected across the x-axis. 13 pi over 6 is going to be that plus 2 pi, or 12 pi over 6. So it's going to end up where the original started. Minus 11 pi over 6 is going to be that minus 2 pi, so back where it started. And then 7 pi over 6 is going to be our fourth answer, and that's going to be that plus 6 pi over 6, meaning plus pi, so rotate it by 180. And we are going to then note that this has the same reference angle for all our answer choices. What that means is if we plug this into a calculator, we're going to get the same result aside from whether or not our answer is positive or negative. From here, all we need to do is determine which quadrant's cotangent is positive and which it is negative, upon which we can make our judgment call as to which one is the odd man out. So cotangent is 1 over tangent, which is cosine over sine. And we know that this is going to be positive and negative just where tangent is positive and negative. So positive in 1 and 3, negative in 2 and 4. So now we have to pick the answer choice that is the odd man out from the original. And there is only one that does not share the positive sign. It is going to be in quadrant 4 and is our first answer choice. So our answer is going to be negative pi over 6. Is going to be the angle that does not share a common cotangent to positive pi over 6. Now, to show my point, let's go to a calculator. First, before we do any numbers, we're going to have to put it into radian mode. Otherwise, your calculations will make no sense to your calculator. And last time I tried this, my browser closed, but I must have done something else wrong. So let's just hope that doesn't happen again. So we're going to plug in cotangent of pi over 6. Move my head so we can see our result. 1.73 dot 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 dot. We are going to get something similar for each of the answers we plug in. Negative pi over 6 is that, but negative. 13 pi over 6 is the same answer as the original. Negative 11 pi over 6 is the same as the original. And 7 pi over 6 gives us the same as the original, which confirms that the first one is the odd man out. Now, other times it'll ask you which is equivalent, and you can use either of the same methods to get there. I honestly think it's faster once you get it down to do the first thing where you do the reference angle and the sign check than to plug these into a calculator. Because when I look at this, I see reference angle is pi over 4. Reference angle is also pi over 4, but this guy's in a negative place. Reference angle is also pi over 4, but this guy is also in a negative place. 9 pi over 4 is going to be the same, so we're going to go with that. But let's move on from this. Radians on the clock. This one is not too bad. All we need to know for these problems is that every time we move 1 hour on the clock, we are moving 1/12 of the entire circle. And since the whole circle is 2 pi, an hour is 2 pi over 12, which is just pi over 6. So whatever time it is, supposing we're still on the right side of the clock, like 12, 1, 2, 3, 4, 5, up to 6, we can simply multiply our pi over 6 measure by the time of day. Here it happens to be 1 o'clock, so that times 1 is itself. Here, if we're at 5 o'clock, it's pi over 6 times 5, so 5 pi over 6. Here, it's 3 o'clock, so 3 pi over 6. Let's reduce that to get pi over 2. Here, we have 5 o'clock, so we've seen this before. Here, we have 1 o'clock, we've seen it before. And just like that, we've already done 5 of these problems. Let's go back to here, arc length, radius, and central angles. So here is a very important thing you're going to need to see in formula. So we're going to go ahead and take a screenshot. I know, you're shocked, screenshot. What we need to know is radius times angle in radians equals arc length. So simply, we need to find the degree measure of the angle given the other two. We also need to show that angle in radians equals angle in degrees times pi over 180. The same deal is going to be true in reverse, but if you flip the fraction. So what we're going to do is need to divide 31 by 18 in order to get the angle in radians. 31 over 18. Now we want to convert that to degrees by multiplying by 180, dividing by pi. And we're done. We just need to simplify to get 98.7. And that was it. Here we have the length of the radius, and we have the angle in radians, so just 18 times the angle in radians is the arc length. That's it. This time we want the length in of the radius, my mistake. So we want to divide the arc length by the angle in radians. So what we're going to need to do is take 98 degrees, divide it by 180, times pi, and we get our radian angle. So let's just throw that whole mess in parentheses because we can, and say 22 over, let me go ahead and grab that, is 12.9. That's all we have to do for that problem. The final section I'm going to take you through on this video is radians, radius, and arc length. In a circle with this radius, an angle measuring that radians intercepts an arc. Find the length of the arc to the nearest tenth. This is the same thing we just did, but without the pictures. So radius is 3.9, angle measurement is 4.8, we want the arc length. So 3.9 times 4.8 is radius times the angle in radians, so we end up with just rounding to 18.7, and that is it. So here, we want the angle in radians, and we have the arc length and the radius. So 21.6 divided by the radius is 2.8 radians, and we're done. For this one, we want the radius in simplest form, so divide the arc length by the angle measure in radians. The pi's cancel. We end up with 4 is our radius. That's all you have to do for this assignment this week. Do your best. You're going to nail it. Have a good one, y'all.